Hey y'all, it's me, Miss B, and today we're talking about geometric sequences. So a geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant. The amount by which we multiply each time is called the common ratio. So looking here, if you look, this is a geometric sequence. I am multiplying by 3 each time I go up. So let me do it with a highlighter, it's a little nicer. So multiplying by 3 each time I go up. Okay, so we're trying to decide if the following sequences are arithmetic or geometric, and we're trying to find R or D. So R is the common ratio for geometric, and D is the common ratio for arithmetic. All right, so looking at this pattern here, I'm going from 30 to 25, 25 to 20, 20 to 15, so you can catch the pattern that we are subtracting 5 each time. Since we are subtracting or adding -5, I do my A2 minus my A1. So -5 is equal to D. All right, this next one here, I'm going from 2 to 4, 4 to 8, 8 to 16, 16 to 32, you should recognize the pattern as times 2 each time. So to find, what am I doing? So to find the difference each time, I'm going to take my A2 divided by my A1. So that's going to be 4 divided by 2, which is 2, and that is equal to my R value. That common ratio. All right. Then this next one here, I'm going from 10 to 5 to 2.5 to 1.25, and you can see there that we are actually dividing by 2 each time. So I should have labeled these, but this is arithmetic, this is geometric. And because we're dividing, this is geometric, so I'm going to do A2 divided by A1 to find that value. So 5 divided by 10 gives me 1/2, which is my R value. Okay, this next one here, from 1 to 8, that's times 8. 8 to 27, that's not times 8, so that's not going to work. So no, well, that's confusing. I'm trying to simplify it. So it's times 8 times 8. It's not true. Okay, then let's do our arithmetic. So this is +7. This is not +7. So because it's not arithmetic or geometric, it's going to be neither. Okay, what this one is actually is 1 to the 3rd, 2 to the 3rd, 3 to the 3rd, and so on. All right. So to find the general term of a geometric sequence, here is our equation. I would really focus on this one down here. It's a sub n equals a sub 1 times r to the n minus 1. These say the exact same thing. One is just a cleaner way of writing it. Okay, so we're going to write the equation for the nth term of a sequence. So from 1 to 3, I am multiplying by 3, multiplying by 3, multiplying by 3. So R is equal to 3. This is my a sub 1 right here. So I just plug it into my equation. And because I'm looking for the nth term, I'm looking for a sub n. So a sub n is equal to 1 times R to the n minus 1. If you wanted to be fancy, you could just write it as 3 to the n minus 1. Okay, let's look at this next one here. So we have a geometric sequence. Write r and find the nth term, then find the value of the 8th term. So identify r, write the nth term, value of the 8th term. So it's 3 parts. So each time, 3 to 12 is 4 times 4 times 4. So I'm multiplying by 4 each time. So r is equal to 4, there's that. I'm actually going to write that down here. R is equal to 4. Then I need my equation of the nth term. So a sub n is equal to a sub 1, 3, times r to the n minus 1. And then it asks me to find the 8th term. So I'm going to find a sub 8. So I plug in 8 into this equation. And so I have that's equal to 3 times 4 to the 7th. And so I have to do 4 to the 7th first. That is 16,384. Then I can multiply that by 3, and I get 49,152. So that is a to the 8th. So there are all 3 parts that I need for my final answer. All right, and then we'll save this last one. All right, I believe this is our last section. We're trying to find the sum of a finite geometric series. So here's the sum written here. S of n is equal to a sub 1 times 1 minus r to the n all over 1 minus r. And of course, r cannot be equal to 0. All right, so we're going to find the sum of the first 18 terms starting here. So we need to find r, we need a sub 1, we need r, and we need n. So go ahead and pause and find those. All right, a sub 1 is 2, r is going to be -4, that's what we're multiplying by each time. And then, I'm having trouble moving that, n is equal to 18. So S of 18 is equal to 2 times 1 minus -4 to the 18th. We do not need that in parentheses. All over 1 minus -4. So you can type in your calculator just like that. You just need to make sure you close your parentheses. So go ahead and pause and try that. What you end up with is -2.75 times 10 to the negative, just 10 to the positive 10th. Okay. For this next one here, I again am trying to find that value. So I need a sub 1, I need r, and I need n. So a sub 1 is a little bit harder to find this time because I have to actually plug it in. So a sub 1 is 3 times 2 over 3 to the 1 minus 1. So I get 3 times 2 to the 3, 0. So I get 3 is that value for a sub 1. R is going to be this value right here, that 2/3, because that's what's changing each time. And in fact, this right here will always be your ace of 1. So this is ace of 1, this is R, and then N is equal to this number right here. So that right there is your N. So N is equal to 8. So then we'll just plug it all into the equation. So we have S of 8 is equal to 3 times 1 minus 2/3 to the 8th all over 1 minus 2/3. What you end up with when you plug that into your calculator, you should get 8.65. So make any corrections that you need to on that one. All right, finally I have a word problem. So let's pick out that information. I need ace of 1, R, and N. So for this first one here, it says, a union contract specifies that each worker will receive a 5% pay increase each year over the next 30 years. One worker is paid $20,000 in the first year. What is this person's total lifetime salary over a 30-year period? Okay, so this piece, 5% pay increase, is important. The $2,000 the first year is important, and then the fact that it's over a 30-year period is important. So now we just have to put that where that goes. So my ace of 1 is going to be that starting amount. So that 20,000 is my starting amount. So my first year. Then my R is going to be equal to the 5% increase. So I have to do 1 plus 0.05 to get 1.05 is equal to R. And then my lifetime salary over a 30-year period. So my N is 30. So what is my salary each of those 30 years? And then I'm adding them all together. So here, let's go ahead and plug this stuff in. I have S of 30 is equal to 20,000 times 1 minus R to the N over 1 minus R. So go ahead and plug that into your calculator. What you end up with is $1,328,776.95. So this is in total and before taxes. So over a lifetime of 30 years, this person makes $1,328,000 in total. Of course, he never sees it because he has got to pay his rent, he's got to pay his taxes and buy groceries and all that good stuff, but he did over that amount of time make that $1 million. All right, well,